This is part 2 of R.6, radicals and rational exponents. We'll do a few more radicals today and then go into those rational exponents. But before we begin, let's see if we remember what we did last time. Here we have a rational expression that has a radical in the denominator. And hopefully you remember that we can't have radicals in the denominator. So since that radical is attached to something else by an addition or subtraction sign, in this case subtraction, we have to get rid of it by multiplying times its conjugate. So go ahead and push pause, give that a try, and then come back and see if you got that right. All right, its conjugate should be 1 plus square root of 3. We take the opposite of the radical, but we leave 1 the same. All right, we're going to distribute on top. All of these need to be grouped so we can distribute and FOIL. We get 2 plus 2 radical 3 for our numerator. And our denominator, 1 plus the square root of 3 minus the square root of 3 minus 3. All right, so to simplify that denominator, the positive square root of 3 and negative square root of 3 would add to equal 0. And then 1 minus 3 is negative 2. On top, I see that there's 2 in both of these, so I'm actually going to backtrack and refactor out a 2. 1 plus the square root of 3, so that I can simplify, because 2 divided by negative 2 would give us a simpler answer of negative 1 plus square root of 3. Or some people might choose to distribute that negative all the way through, negative 1 minus the square root of 3. Either one of those answers would be acceptable as a final answer. Okay, so let's look at some more radicals, but today when we do a radical, it's not going to be a square root, it's going to be a cube root. Cube roots work the same way as square roots as far as when we have a number and a variable, we want to look at them separately from each other. So when we look at the number 27, we need to find, instead of a perfect square that goes into it, we need to find a perfect cube. So let's make a list of what our cubes are. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, ding, ding, ding. 4 cubed is 64 for future problems. 5 cubed is 125. Oops, sorry. So one of those numbers is what we are looking to find that divides evenly into 27. Now, when a number on the list is that number, that means we don't have to split it up, because 27 is in fact a perfect cube. So the cube root of 27, this was 3 cubed, so that means the cube root of 27 is 3. And just like with the exponent or the variables that we did before, we want to divide. So a cube root is the same thing as the 1/3 power, just like a square root was to the 1/2 power. So we want to multiply 9 times 1/3, or essentially divide by 3. And since 9 is divisible by 3, that's good. So we don't have to do any other simplifying. We can just divide. 9 divided by 3 is 3, and we're done. Unfortunately, just like with the square roots, the numbers they give us aren't always perfect cubes, nor are the exponents always divisible by 3. So we'll have some more manipulating to do. So let's take a look at number 8. Here we have another cube root. We want to take a look at the 48, and we want to find a cube that goes into 48. So we need something from that list up there. We want the biggest one that goes in. Obviously 64 and 125 are too big. 27 does not divide in evenly, so 8. 8 divides into 48 6 times. So we break it apart, cube root of 8 times the cube root of 6. Always the perfect cube on the left, just like with square roots. All right, cube root of 8 is 2 times the cube root of 6. All right, moving on to our next value, we have x to the 12th, and 12 is divisible by 3, which is awesome, so we can just go ahead and divide it. 12 divided by 3 gives us a simplified version of x to the 4th. Now y to the 14th. 14 is not divisible by 3. So we need to break it apart into a number that is divisible by 3 times the leftover stuff. So the biggest number less than 14 that is divisible by 3 would be 12. And to make it add up to 14 when we multiply them, the leftover stuff would be 2. So 12 plus 2 is 14. And now we have 12, which is divisible by 3. So we have y to the 4th. Oops, and these should both be cube roots. Times the cube root of y squared. Our last step is to take everything that's on the outside of the radical and put them together and put all the stuff on the inside of the radicals inside together. So the 2, the x to the 4th, and the y to the 4th all go on the outside. And then we have our cube root. So inside we would have a 6 and a y squared. Lots of exponents on that one. All right, next we're going to look at rational exponents. And that's a fancy word just for saying that your exponent is a fraction. Rational means it can be written as a fraction. So here we have 27 to the 2/3. We call the numerator the power. So that's like taking 27 to the 2nd power. It'll make it bigger. The 3 is the root. So that would be like taking the cube root of 27. That makes it smaller. So the directions want us to be able to rewrite this as a radical and then also to be able to simplify it. So if we were to rewrite this as a radical, remember 3 is the root, so we'd have a cube root of 27 squared. Now that could also be written as cube root of 27 and that whole thing squared. So you can square first and then take the cube root, or you can take the cube root first and then square. They're the same thing, but one way is easier than the other. I believe that it's always easier to make your number smaller before you make it bigger. Because I don't know what 27 squared is, but I do know what the cube root of 27 is. So I'm going to do the root first. So when I'm solving these, I always do the root first. So cube root of 27, I'm going to do that first, the 3, which is 3. And then I'm going to square that answer. So my final answer is 9. All right, let's try another one. Now we have 9/5 is our base to an exponent of 3/2. 3 is the power, 2 is the root. So again, just like last time, I'm going to do the root first. I'm going to take the square root of each one of these. So the square root of 9 is 3. The square root of 25 is 5. Taking the square root first, just took the square root of each one. And now I'm going to cube it. And I have to cube both of them. So 3 cubed is 27, and then 5 cubed is 125. So I did the root first to make it smaller, and then I cubed each one. All right, here we have an expression that has some normal exponents and some rational exponents. And then we have that power on the outside that we need to distribute to everybody on the inside. So one of our exponent rules here. One thing you need to remember when you're distributing this is that the number, that coefficient in front, gets the exponent too. A lot of people leave out the 3. So the 3 has to be cubed, the x squared has to be cubed, and the 4/3 has to be cubed. So we're going to cube all 3 of those. So 3 cubed is 27. X squared cubed, when you have a power to a power, you multiply. So 2 times 3 gives us x to the 6th. And same thing here. Here's another power to a power. So 4/3 times 3. Well, when you have the same number on numerator and denominator, you can divide those out to equal 1. So we're just left with 4. So y to the 4th. All right, now this one's getting a little crazier, but same idea. Just because it's in a fraction form, we don't do anything differently. We give everybody on the inside the power that was on the outside. So all the coefficients and all the variables, everybody gets that power. So we have 10 to the 3rd, which is 1,000. 5/8 to the 3rd. Remember, we're going to multiply these. So just kind of a reminder of how we multiply fractions. We have 5/8 times 3. Now 3 is not a fraction, but you can make it one. So 3/1. You multiply numerators and denominators. So 5 times 3 gives us 15. And then our denominator would be 8. 8 times 1. All right, so same thing down below. We're going to take 4 to the 3rd, which is 64. And then x to the 1/2 to the 3rd. So again, we have 1/2 times 3/1. That ends up with x to the 3/2. Okay, so we've brought all of that stuff inside our parentheses, but we're not done simplifying yet. We have more than one thing we need to simplify. First of all, 1,064 have numbers that are in common. So we need to figure out what number goes into both of those. Since they're both even, we know for sure 2 goes into both of them. Some of you might recognize that 4 goes into both of them, but we want the biggest number that goes into both of them, which happens to be 8. So we want to divide both of those by 8. So 1,000 divided by 8 is 125, and 64 divided by 8 is 8. Now the other thing we need to simplify here is we have x and x, the same base. So we need to simplify these exponents. When we're dividing, to simplify exponents, you subtract. So we need to take 15/8 and subtract 3/2. Now hopefully you remember, in order to subtract fractions, they have to have the same denominator. So multiplying doesn't matter, but when you're adding and subtracting, they have to have a common denominator. So we need to change the 3/2 so that it has a denominator of 8. That means we have to multiply the top and the bottom by 4. So now we have 15/8 minus 12/8, which equals 3/8. Because when you're subtracting, you only subtract the numerators and you keep the denominators. So that means our x's, we'd have 125x to the 3/8 in our numerator, and then our denominator would just be 8. So rational exponents follow all the same rules as regular exponents. You just got to be careful when you're adding and subtracting and multiplying those fractions.